Hello, so today what we're going to be talking about is power on departure stalls. So, in the world of aviation, as flight students, you have to learn about the way the airplane stalls and reacts at very slow speeds and when we exceed what we call the critical angle of attack. So, first off, I want to get started by saying that, most people think that stalls can be very intimidating at first, but in a stall, we never turn the airplane engine off, not at all. Typically, people think of a stall being when your car quits on the road or when you have car trouble on the side of the road. But in the airplane, a stall has to do with lift and the way lift goes over the wings and how during a stall that lift is not going to be going smoothly over the wings, resulting in what we refer to as a stall. So first of all, let's talk about what actually is a power on stall. So there's two types of stalls: power on and power off, the two main types. But today we're going to be dealing with power on departure stalls. Departure stalls, power on stalls, we're setting up a takeoff configuration. So we've just taken off, and all of a sudden, well, maybe we pitch up too much and our speed gets slow and then we stall. So that's kind of the situation to think about. Now, of course, we're going to be practicing these up at altitude 4,000 feet, is what I usually do as a flight instructor, and the way that I teach my students how to do power on stalls. So what we're doing is what we're going to do is we're going to pitch the airplane up. What we're going to do is we're pitching the airplane up to where we go about 15 degrees pitch up and exceed that critical angle of attack, which when we exceed the critical angle of attack, what we're doing is when smooth airflow can no longer flow over the wings. So that's exactly what a stall is. And that's a loss in lift. So as we know, to maintain straight and level flight, lift must equal weight, just like in normal physics. And so that's what happens during a stall is we don't have enough lift to overcome the weight of gravity that's pulling us down. So let's just review what angle of attack is. Angle of attack is just the angle between the chord line of the wing and the relative wind. And let's go ahead and talk about chord line too. So chord line is that imaginary line between the leading edge and the trailing edge of the wing, that imaginary line there. And the critical angle of attack, and stall go interchangeably. So that's when a stall is when we exceed the critical angle of attack, or critical alpha, as it's sometimes referred to. One of the things that I always like to go over is why we do these stalls. So why do we go out and practice these? So of course, we don't practice stalls to practice stall entries. What we're doing is we're practicing these to practice the stall recovery process. We want to learn the proper techniques for recovery and get used to the stall tendencies, what the airplane does, and how it feels when we're going into these. So let's go ahead and step into how do we actually do the stall. So let's go ahead and what we do for any maneuver, we want to clear the area. So do your clearing turns, just like always with steep turns or any type of flight maneuver. Let's see. So what we're going to do is we want to pitch the airplane up, whether we reduce the power or pitch the airplane up, to get the airplane slowed down. What we're doing is we're simulating that we're taking off when we're already at that slow airspeed. So what we want to do is get the airplane between 70 and 75 miles per hour. Usually that works well for the trainer aircraft, the 172s, your Piper Cherokee 140s, 160s, etc. So what we're going to do is we're simulating climb out. We're simulating climb out at best angle of climb, VX. And what we're going to do is, as we get slower, we're going to gradually add full power and keep pitching that airplane back with the yoke. So keep coming back. What we want to do is we want to go all the way full power, and we're pitching the airplane, gradually pitching the airplane up and up. And what happens is the more we pull back on that yoke, the airspeed's getting lower, our angle of attack is increasing, and all of a sudden the airplane wants to pull off to the left with P factor, left turning tendency, so we have to counteract that with the right rudder to make sure we keep the nose straight. And then as we get really slow, you'll notice a little shimmy, what I call a shimmy. And the shimmy is when the stall breaks. And so as soon as that stall breaks, we lower the nose and recover. Again, we already have full power applied, so we want to recover and gain altitude as quickly as we can, because again, we're simulating that we are at already slower airspeeds. That is the basics of a power on stall. Of course, we'll talk about more when we go flying and go a little bit more in depth. Again, if we have a wing drop on a stall, when we have a wing drop and signs of an incipient spin, what do we want to do? We want to counteract that with opposite rudder. just as we would for any stall. So, all right, so as soon as that stall happens, just to review, we lower that nose and let the airplane recover with airspeed. All right, thanks a lot. This has been Power on Stall Flight Lesson.